Okay. In these two recordings, I'm going to do some supplemental work on limits, chapter 2.2. And I'm going to cover one more section on limit laws, 2.3. The limit laws are really formal laws, and we really don't think about them too much. We use them all the time. And I'm not going to hold you formally responsible for these on an exam. You might see a couple of questions in the homeworks, but I'm not going to hold them responsible on any exams. That doesn't mean you shouldn't be aware that they exist. So let's start with the supplemental work on 2.2 limits. And one of the things that I did not address were one-sided limits. So let's take a look at an example what we mean by a one-sided limit. Let's take a look at the limit as x approaches 0 from the right of the natural log of x. Okay. Now, since we cannot use a direct substitution for this, because the natural log is not defined at x equals 0, it's also not defined at negative values of x either. But let's take a look at this, and this is called a one-sided limit. Notice that we're approaching 0 coming in from the right-hand side. That is positive numbers approaching 0. Numbers getting smaller and smaller of the natural log. Of course, in order to do this, it'd be nice if we knew what the graph of the natural log looked like. So if you don't know what it looks like, let me pull this graph up on my calculator, and I'll adjust my window. And by the way, if you're reading, if you're actually watching these videos, which you're supposed to be, you need to be practicing how to use this device, the calculator, the TI-84, or whatever calculator you've decided to use. You may not use a calculator that does symbolic mathematics. This is only representational and computational mathematics on this calculator. So any other devices, if I recognize the answers that look like they're canned answers, then you're not going to get credit for them. And also on exams, you will have to show every piece of work for every single problem, regardless. You use the calculator to check your results, basically. So let's take a look at this. I'm adjusting my window here. I'll make one more adjustment to this, okay. All right, and that's a good enough look at what the graph of the natural log looks like. Now, notice what we're really talking about here, that the y-axis, which is the line x equals 0, is actually a vertical asymptote for this function. So in many of these types of limits that I'm going to address right now, I'm just using one example here, but the same approach can be used. What I'm going to do, and I will ask this on an exam, this is the way that I'm going to approach it. I'm going to use and expect a numerical approach. So I'm going to choose a value very close to 0 coming in from the right-hand side. Now, on an exam, I may actually pick this value for you or just allow you to pick one very close. So I'm going to choose for this example, x equals 0.0001. That is, let x equal to 1/10,000. That's pretty close to zero coming in from the right-hand side. Okay, again, this is a one-sided limit because the limit doesn't exist coming in from the other side because the function doesn't exist there. Now, in order to evaluate what the function is going to give me, that is the natural log of 0.0001, I'm just going to use my calculator. This is one case where you are going to use your device to come up with an answer. So there are places where you can, and there are places where you cannot use your calculator to come up with an answer. This happens to be one where you're expected to use it. So I'm going to go second calc value 0.0001. Right there. And then I'm going to press enter. And this is telling me that my y value, or my functional value, f of x, is negative. So my y value is equal to, and it's approximately equal to, negative 9.2103. That's 4 decimal places of accuracy. Now that's what my calculator is telling me, and I'm rounding off to 4 decimal places, which is, more than enough accuracy here. Now, you may not be convinced as to what the answer is. So what I'm going to do in this example is I'm going to choose another value of x even closer to 0 coming in from that side. Okay. So let me choose x equals 0.000001. That's like 1/1,000,000th now. So that's getting very close to 0 coming in from that right-hand side. All right, so I'm choosing another value. Now, again, typically, I think on an exam, I will choose the values for you that I want you to use. That way, when I grade these things, I can have some consistency in my answers instead of having people's answers all over the place. So once again, I'm going to go to my calculator and I'm going to calculate the value of the natural log of 0.000001. Point 0.000001. Okay. And that only takes me down to negative 13 point something, whatever that is. You could see it. Negative 13.8155. Now, you might still not be convinced. And so my advice here is, just for your own sake, choose another value even closer. Maybe pick 1 times 10 to the negative 10 power. But anyways, the point is here, this is about negative 13.8155. Now, some of you may not be convinced as to where this is going, even though you can see what the graph is telling you when you looked at the graph of the natural log. But this is actually headed for negative infinity. This is a function, by the way, that is unbounded below. So the closer and closer and closer we get to 0 coming in from the right, this thing is headed for negative infinity. So this is headed for negative infinity. So the answer here to this limit question is negative infinity. Negative infinity. Now I'm going to bring up something right now just as a comment. When you say the limit of a function as x approaches zero coming in from the right, in this case, the natural log function is equal to negative infinity, either negative infinity or positive infinity, that's not really a limit, okay? Because infinity itself is declaring that this thing just goes on forever. So the closer and closer you get to zero, the bigger and bigger negative numbers you're going to be getting. So it's not really a limit, but the textbook and the web assigned questions are going to expect to see either positive or negative infinity as answers. Okay, so this is one example. It's a supplemental example from chapter 2.2. Something that I didn't get to cover the first time through on the other recording. So let me pause this for a second. All right, so we're recording again. So let's take a look at this limit here. Okay, a nice friendly polynomial function that we're using for a limit here. Now, you could just use direct substitution, but my point here is from chapter 2.3 to demonstrate to you what the limit laws are. Now, these are just properties of limits. And again, as I mentioned in the other recording that I started this with, I'm not going to formally ask you any questions on these properties on an exam. But you should know they exist, and you might see them in some web assigned problems. So what this says is that the limit of a sum is equal to the sum of the limits. So I'll show you this here. Limit as x approaches 1 of 2x squared minus the limit as x approaches 1 of 4x plus the limit as x approaches 1 of 5. So we've taken one limit and have broken it up into three limits. These are limit laws. It says the limit of a sum or difference is equal to the sum or difference of the limits. Then we have other limit laws, which says that the limit of a constant times a variable is equal to the constant times the limit of the variable. So let me apply this one more time. Now, again, this is very tedious, and we use these all the time without thinking about them. That's why I'm not going to hold you to these or ask any questions about these on an exam, because we use these all the time without thinking about them. Just like when we're adding numbers, we don't think that we're using the commutative property of addition or the associative property of addition or any of those. So let me write this one more time. Now, notice that the last one on the right here, which is the limit as x approaches 1 of the number 5, notice that I didn't move that constant out in front of the limit, okay? Why? Well, because there's the limit property that says that the limit of a constant is just equal to a constant because there's no variable. So that one on the far right-hand side is just 5 because the constant, the limit of a constant is a constant. The other two limits here, I can now use direct substitution, okay? So when I plug in x equals 1 into the first one, which is x squared, I get 2 times 1, which is 2. The next one, I get minus 4 times 1, which is negative 4. And the last one, the limit as x approaches 1 and 5 is just 5. So the answer here is that the limit is equal to 3. So it's 7 minus 4. And so the limit is equal to 3, which is the same thing that you would have gotten if you had substituted x equal 1 into the original function without using the limit laws. So you can see this is rather tedious if you were going to use this formally every single time, which is why I'm not holding you to this, by the way. Okay, but I expect you to know they exist. You should know they exist. Okay. Now, once again, I'm going to tell you that you have chapter review documents, which also have a lot of other YouTube videos on there, links that you should go to and you should watch, in addition to watching these. All right, so let me stop this recording. And we're done.